For the drawing then, we'll go into New and the My Landscape. Again, if you haven't produced this title block, use the standard SolidWorks A or B size. What I'm looking for is the creation of the views and applying the dimensions. As you progress and become more comfortable with the software, then you'll want to build in these other items, being able to utilize the layers, being able to utilize the title blocks, the sheet format, and the document template. And I had to look. I've posed the question several times in previous videos. So I got out one of the SolidWorks books, and the definition: the sheet format file contains the drawing borders and title block, standard notes, smart notes, link to custom and special properties, the anchor points for the tables, and the custom properties for that document. Right, so for the drawing document, not necessarily the part of the assembly. The drawing template then includes the document properties. So let's see, custom properties versus document properties. So have to another one of those finer points. All right, so document properties. So I would think like the drawn by and the drawn date. The link to the sheet format file, since if you create the drawing template, you may want to go to, if it's for a specific company or organization, then you would want to go to that sheet format, have that quick link, and then predefined views. So we haven't done any predefined views just yet, but that is possible that we could set up a view for the front and the isometric, and so when we bring in a part, it goes to those views automatically, semi-automatically, as the case may be. All right, so I'm going to bring in P6-11, and since it started, we'll grab the create multiple views, and I'll just go ahead and grab those two. So this being the assembly, I'm going to pick those out, and I'm going to turn off of under the view, turn off the origins. So I think that view would be something that I would turn off in the sheet format, possibly the document properties, but that would be one to explore. All right, so we have the isometric, we have the front view. This is the one that I would like to see with the solid threads. And if you're going to print these, I always hesitate. The shade looks nice, having that shaded detail, but since ink is $1,000 a gallon, stay with the hidden lines removed or the hidden lines visible. All right, we'll save you some method there. So if we go into the view, let's see. I will go back over to the view palette and bring in a couple of more isometric. We haven't talked too much about the dimetric or the trimetric, so maybe I'll bring in a trimetric for the exploded view. And that one's still listed as the solid threads. And if you didn't have any luck with the solid threads or the assembly cut, really what we're looking is to be able to go through this process again. Go through as much of this as you can and start to make those connections. And just like the per standard video, after 20 some odd years of using SolidWorks, I still find things that I didn't know. So this is a constantly evolving iterative process that you're going to be going through. So if I put the bill of materials up there, then maybe that can go that way. Do something like that. So again, these are just kind of options to visually display your data. and whatever gets the job done, that we can, there it is, tables, that we can kind of progress as we go. All right, so I did not fill in any part numbers. I did not create any material, so I need to possibly think about those. And then this is the point. I don't remember if I went to the tables. So since I've already inserted, it's not going to help right now. But if I go to the tables and I said that my revision table was going to be under the DIMS and my bill of materials was going to be under DIMS, then it would come in as long as I was listed as per standard. Then it would come in per the standard that I've created. So let's just double check that, since in this session, in this install on a computer, I'm in the ISO, but I'm not in the ISO modified. So for the per standard to work, let's grab one of the dimensions, linear, and it's listed as none. That doesn't help me if I have that previous install. So let's go ahead and grab my ISO modified. And if you haven't done this, this is more of just, again, informational. So if I go back to linear, and now I have it set to DIMS. So I'm gonna have to look and see about that as a default or what have you. But for this to work, and one of the points of confusion is making all these connections and associativity is when is it active and when is it inactive. So let's go up to annotations, and I'll put in the auto balloon. We'll line those up, I think probably to the side. I don't know why it quite did that, but let's go ahead and hit OK. And we'll highlight number 3. Keep in mind that we have the grip out here, and since these are the same, we'll reapply it. All right, so the balloons came in under the DIMS per the standard. And that all looks pretty good now. We'll just do a little spacing. And a shadow, what is that? Interesting. So hopefully that will update and go away. So let's go back to the assembly. One of the passes that we're going to make with the drawing is now I can, if I haven't done it previously, I would be going back. And so we haven't done too much with the materials, so let's edit the material. And this time I'm going to switch it to an aluminum alloy. So we have 6061, just 6061 alloy. And I'm going to apply it. Yes. And then somewhere in our favorites, I'm going to be able to, with that selected, add it. And maybe I'm going to be doing a lot of 6061, so I'll move it to the top of the list, and then we can close. And then the hex bolt, we'll collapse that. Hex bolt material 6061 alloy. The hex caps, and this is linked back to the toolbox, so I don't know that I want to mess with those, but we call these out as a stainless steel or as a standard plain carbon steel. So let's go ahead and rebuild. I'm going to move that again and see if that follows it. Nope. Alright, so the other thing that it did follow it. Alright, interesting. So let's open the assembly back up. Go ahead and collapse that. Go over to my properties. Oh, this is in the assembly. So we need to open Make sure I'm doing this, because if I go to the file properties, configuration specific custom is empty, I still have to go to my custom properties and give this a file name or a part number and fill out the custom properties. So I'm just going to use the project revision A, finish. Let's make it a black anodized, modeled by me, today, and apply, and make sure to save it. We can close it, open up the next, and we'll go through the same process. Because this was configuration specific, I am going to have to be a little bit concerned that because the part number is just visual, I may have to populate it in both, but the bill of materials and the part numbers are not attached to that to the solid thread configuration, so it shouldn't be that much of an issue. But part of our verification is to double check. So we apply that, we save it, we close it, and then save that. Oh, and I gave this, actually usually the assembly would be 1. Varies, finish, not applicable, modeled by. So having this custom properties interface is a time saver as opposed to going through and having this information travel with the part or the assembly template and having to go through and populate it as we go. So again, if you haven't gone through that process yet, don't worry about it. You know, we'll build into it. This is all of the things that you can do. So if these are blank, it's not that big of a deal yet. All right, so if I expand that out, we'll be like Excel, and you know, pretty much this being a purchase part, we're not going to make those. Then we can have this built in, and looks like I got a little with the little off on the names anyway, so whichever. Okay, and rebuild. Okay, so now my part numbers, anything that you notice, that's the time to correct it. We go to the next sheet. We have the parts in. So this time I'll do the view palette. It's not open currently, so we'll go to the list, and let's bring the body in. So for the body, I think I would like to have the top view because I really want a section view for that geometry. And because the predefined per standard is to have that go to the center, and I loaded up my ISO modified, now I have that that center line come in on the correct layer. All right, so little time savers that, again, you'll work into if you haven't prepared it yet. It's something that you'll want to practice and become comfortable with. All right, so in the drawing, I want a section view. That section view is going to be aligned. It snaps. So let's do that again because my fingers were ahead of my mouth. Under the drawing and in the section view, we can set the direction vertical, horizontal, half sections, and then aligned, and whatever the kind of the broken, I guess notch offset, single offsets, arcs. All right, so we'll go ahead and accept that, drag it out, and put it in place. So it automatically put in my center line or center mark. Don't know that I need a center line, so we'll go ahead with it. And I always think the section description is a little bit too large. Probably will go back in the ISO modified and change the fonts for those. That just seems a little overbearing for a an A size sheet, and since the section view, let's go ahead and, don't know if I can drag that out just a little bit to clean it up. All right, so grabbing those endpoints, and that might be something that I want to put on DIMS, or I would make a section layer and then have it be part of that that standard. So really a lot of power going on there that I haven't really taken advantage of before. All right, so let's go ahead and add the next sheet. We're on our first pass, so I'm just establishing these. We did the begin assembly, which is the same as going to model view, and then we did the view palette. So let's look under the file, and open in SolidWorks is the hex bolt. So if I drag and drop that, it should go to model view. And I don't need a section view for this. I think maybe I would want to look at the bottom. And then if I was going to generate a projection, all right, so this is still creating the multi-views. So I think I'll just do the bottom. I don't have to have both of those. Now, and it's asking me to place it. So that looks pretty good. When I go into the projected view, then it will show it. And we'll go ahead and put the isometric up there. So that looks pretty good. Scale-wise, we could maybe jump up, see what 1:1 looks like. These aren't overly taking over the real estate. And if that is looking a little big, we can always go to the custom scale, do a half scale, set that view. Let's go back and take a look at that one. Yeah, probably the same thing, 1:1. And then the custom scale. All right, so we've got our section. That's pretty much the detailing. So going in on the second pass for two drawing sheets, I think our assembly sheet's looking pretty good. Our detail, then we can start dimensioning. And normally, if you haven't set up your modified standard, then you would go in and you would select for dimensions, and we would be doing that that previous process. So since I have it set up for the standard, it's going to go to DIMS, and then when I go to the center marks, it will will change. Let's see, I want to grab that thread so that I can see the M20 by 2 machine threads. That's still kind of a strange call out, but I need to double check the standard on that. And then I want to check the whole call out and see if this gives me additional information. So basically, counterbore, I'm okay with that notation. It's maybe not exactly a counterbore, but that symbol shows me and since we're in inches, this is doing the conversion, so if you wanted to switch over to metric, that would be fine. So the diameter for the tap drill to 3-inch 0.05, and then the 1.79, so this just became a duplicate dimension. And the thread callout then, so to that first segment. So if I wanted to keep that to reference the stack up, I would put that as a reference dimension. I'm not sure what I did there. Oh, maybe I didn't get it applied. Try that again. Okay, so that looks good. Make sure to click on it. We're clicked out. Highlight the 1.79. All right, escape so that I'm not in that command anymore. Make sure. Okay, so that goes to a reference dimension. I'm okay with it updating the size. I think for purposes, this would be helpful to have the hidden lines visible so that we can see those too. So when I put in the next, oh, and I did manage to duplicate it. So I had a video blink since that one came back. Interesting. All right, so let's go into the annotation. We'll pull out the whole call out. So it's not picking up the thread. So in that case, let's just go to the smart dimension and jumped into the relations. All right, so yeah, relations snaps smart dimension. Must be getting button happy. So M6 by 10, and would like to designate that as 2 times. Maybe we put in the note through near wall. Through wall. All right, something along those so that it has that notation that it's not going all the way through the part. Tell you what, since those are at different levels, I need another view anyway. So that being the case, let's go with the center line. And if I just select the view, okay, applies it and gets the whole thing, where the geometry doesn't always do that. So for this one, we're going to have to go back to 1/2. And we can get that a little bit closer to depth. I'll go ahead and finish out dimensions. So if I go to the shoulder, 3.05. So the 0.71 to the 3.05, and then the thread call out for 0.98. All right, so I'm going to get rid of the 3 point, and this really should be a min. So if we go to its tolerance and I pick min, all right, so 0.098 minimum engagement gives it enough clearance that the 23 millimeters in the chamfer won't end up in a bind situation at the bottom of the hole. All right, move that over a little bit. I need one more projection then. Projected view will bring this off this way, and that helps with the detail. So I will pick the view again, annotation, center line, and make it the selected view. And then for positions, we're going to have one shown and one hidden. That coming off that way, and that one, since that one's cut out, and by the view. So not a best practice to dimension to the hidden object, but I think in this case it's probably better as far as reading it and our geometry. Okay, so kind of clean these up, figure out which way to point it. And I think that gets enough geometry. Maybe you could put that call out over here, but for our purposes, we'll go into the next one since this video is getting kind of long. And we want, let's see if it's going to pull up the cosmetic thread again. Make sure I'm picking. dimension could not be created from the selected items. Okay, so not sure why it's not liking the detail, but let's go ahead and we'll get this started. So for the grooves, and the process of machining the grooves, that putting this on a lathe and generating that overside geometry, I think we're going to be better off just adding those in. Okay, and then the 20 millimeters to the outside. Can do 25 over the flats, and more than likely something like this would be bought as hex stock that was maybe 1 inch. We might be able to find metric, so that would be something that I would include on the on an add-in video. The call out, for this would probably turn it around on the lathe and just take the 45 by whatever that works out to, a couple millimeters. Since that's really not in the detail, I don't know that I can pull that out as an auxiliary view, but let's see, looking at it that way, that doesn't help. I need to be looking at it that way, so let's go ahead and go into the drawing view and bring off a projected view. I don't think the auxiliary is really helping me there. So that will get what I want, but I really don't need all of the geometry, so I'm going to create a cropped view and sketch a closed profile. So that being the case, usually a circle or something along those lines will be helpful. So drawing, crop view, and if I wanted to break alignment, we can go into the right and break alignment, break alignment. We can put it over here a little bit. And then when I dimension for the chamfer, we'll see if the chamfer will apply to that, since it wasn't specifically meant to be a chamfer or generated with the chamfer tool. So 2 millimeters by 45, and that could be assumed to be all around. All right, so these are kind of optional views to help help generate the geometry. I could also try and rotate this, and this would be a good example to close on. Let's go ahead and save. And if I go to rotate this, and we'll just leave the naming. Looks like the title block's updating okay. If I go to rotate this view by 60 and apply it, it's going to warn me, and almost all my dimensions went away. So, no, not quite 60. Okay, now I've just managed to get myself out of sequence. Let's go ahead and do the 90. Okay, so I could have rotated it like that and then ended up with the chamfer over here. So both of those work, but notice all my dimensions disappeared when I did that rotate after I applied them. That's always the warning with it. All right, so again, take the drawing to the to whatever level you're comfortable with, and then basically be able to create the views, apply some dimensions, and we'll work and build out from there.